So this workshop, I'm sure that the faculty members and other research scholars who are participating in this FDP, the knowledge they can gain from this can be put it into practice through designing certain problem statements, which can be implemented by their students in the form of either academic project or in terms of some hobby project. So that these projects which are being developed through the academics as well as the faculty who can take up certain research area in these domains also, they can come out with certain outcome in terms of the research which can be converted tomorrow in the future as a innovative product, can be submitted for various funding projects or the competitions. So I also heard that there are eminent speakers who had a lot of experience in the field of artificial intelligence as well as the machine learning. And also there are certain speakers who has worked and put up the practice of their knowledge into some of the farming equipment and the farming areas. So that knowledge the experts can share with all the participants, and the participants can also gain the knowledge and collaborate with these experts so that they can work together for the future needs of the farming sector. So I wish the organizers all the best and the participant this 1 week, definitely an knowledgeable sessions you can gain from this workshop. Thank you. All the best for everyone.
Thank you, sir, for your enlightening words. Good evening, all. Thank you for joining us on a Monday evening for ATAL's online 6-day program, which is a faculty development program 2024 to 25. This is titled Smart Farming with Machine Learning Sustainable Practices for Modern Agriculture. It is an honor to have our principal, Dr. S. Aravind, and the department HOD for CSC, Dr. T. Satish Kumar, here with us as we explore and understand energy, sustainability, and climate change. Our main focus throughout this session will be on smart farming with the advent of machine learning. It has become a crucial contributor in every field of life. The aim of these sessions is to make future engineers acquainted with cutting edge knowledge to foster innovation in agricultural techniques. We will understand a wide range of topics throughout the 6-day program, from understanding principles and practices of smart farming to integrating machine learning and computers into smart farming. This 6-day program will provide all of us with an ocean of knowledge. And before we delve further into the details, I would like to call upon the HOD for the CSE department at Hitham, Dr. T. Satish Kumar, to talk about his experience and share a few words with us.
Good evening, one and all. I think it's audible to you.
Yes, sir. Good evening.
Yes, sir. It is audible, sir.
Fine. So I just welcome you all for the online FDP on Gupta. Is it audible?
Yes, sir. It's audible.
Yes, fine.
It is audible, sir. Audible.
Fine, good. So this FDP program is on smart farming with machine learning, focused on sustainability practice for modern agriculture, highlighting the transformation of potential of technology in the agriculture sector, especially on the agriculture sector. And moreover, we have just concentrated on the sustainable agriculture practices, were underscored as essential for maintaining ecological balances. This role of technology right now, what we are just having a discussion for the next 1 week on online. It's all about drones, sensors, and AI algorithm. And moreover, we just want to make it as a capacity building on that aim of the FDP program. So this, we have a very good collaboration and a networking with the academic and the industry experts to develop innovation solutions, sustainable agriculture. Building network is seen as the vital for sharing knowledge and as the practice. So with this, I don't want to extend my time. So we have welcomed you all for the session of today. I'm just happy to my colleagues as well as the management, and of course our beloved principal just taking always the right and give a sanction for each and every moment of us. Thanks for everyone. Let's start with that FDP today. Thank you all.
Thank you so much, sir. Before we proceed further, I would just like to inform everybody in the meeting that this is going to be a 6-day session, and I would like to inform you the timings. So from 6 p.m. to 6:30 p.m. today, we will have an inaugural session, which will be ending in a while. After that, we will be beginning with our first session from 6:30 p.m. to 8 p.m. And our second session will go on from 8 p.m. to 9:30 p.m. It will be a 1.5 hour session. And the coming 4 days, from 21st January to 24th January, we will be having 2 sessions each. The first session will be from 6 p.m. to 7:30 p.m. and the second session will be from 7:30 p.m. to 9 p.m. On the final day, which is 25th January, we will be having 3 sessions. The first one will be from 2 p.m. to 3:30 p.m. The second session will be from 3:30 p.m. to 5 p.m. And the final session of this entire FDP will be from 5 p.m. to 6:30 p.m. After which we will close the entire session by 8 p.m. So that has been displayed as follows.
Shreya?
Yes, sir.
Yeah. Somashekar sir already joined here.
Yes, sir.
Please take the confirmation.
Yes, sir. Somashekar sir, are you here with us?
Yes, can you hear me?
Yes, sir, you're audible.
Okay, so do you want the video to be on or off? Either way is
That's
fine.
up to you, sir.
Okay, sure. And I'll keep it off.
Okay.
Maybe sometime I'll keep it on and then after that I'll switch off.
Sure. So, without any further ado, let us begin with our first session, for which I would like to introduce Mr. Somashekar Gupta T. He has been working as the Global Product Manager at Signify Innovation Labs in Cambridge, UK. He has 15 years of experience and is lauded for his amazing analytical, planning, and communication skills. And with this, I would like to hand over the stage to Mr. Somashekar Gupta. Thank you for joining us, sir.
Hi ma'am, you can hear me well, right? Okay, so can I start sharing my screen and start the session, or do you want me to wait another 2-3 minutes so everybody joins?
You can carry on, sir.
Okay. Can you confirm me whether you can see my screen?
Yes, sir, it is visible.
Yes, it is visible.
Okay. So you can see my screen. Okay, I'll just put it into presentation mode now. Yes. Okay. Can you confirm me once again? Everything is fine?
Everything is all right, sir.
Okay, excellent. Good. Thank you.
It's not.
Thank you.
It's not in presentation mode.
Okay, you are seeing the other screen. That means okay. So is it fine now?
No.
Can you confirm is now okay?
No, sir.
Okay. So what screen you are seeing? Can you tell me? Because I'm using two screens now.
PPT screen without presentation, sir.
Sir, on the bottom pane, you will have a button that says slideshow.
Yeah, I did that because I'm using two screens.
All right.
Okay, a laptop as well as the monitor. So that's where I got it. Yeah. It's actually taking, okay. Maybe I should stop sharing 1 second. I will do a share. Is that perfect now?
No, still it is same.
Okay.
Yes, it's same, sir.
Same small screen?
Yeah, small screen and left side, all the this one slides are visible, sir.
Okay. Okay, so then I have to share the full desktop. Maybe I'm only sharing the presentation. That's where it is giving the problem. Okay. Should be
Now it
fine
is,
now.
yes, now it is okay.
Yes, sir.
Yeah, it is perfect, sir.
Okay. Yeah. So okay, sorry for that. I'm using two screens, so it is got confused a little bit. Okay. So yeah, so thank you very much. Thanks for all the participants and also lecturers, HODs, and one and all. Thank you for joining the session. It is very glad that you have received a prestigious thing which is required for all the institutions, and you are playing a good role in developing the young minds to get into a technological aspects of it. And I know Raghu from quite some time, and we studied together. And thank you, Raghu, for making me also supporting in this in this aspect of delivering my part into the new to the new young young kids, right? Okay, so let's get into more details of what we are going to talk on the topic today. I have some experience on the smart connected systems, but not on the farming. But now with the topic of smart farming, I learned a lot in the smart farming. Even though the company which I work in UK is started with the farming technology, but slowly they end up into a lighting division, but not into the farming. The same technology we use today for swans for lighting, whatever they started in 2012. Um, so I have some knowledge which I can share with you all today and tomorrow in two sessions. Today we will concentrate more on the importance of farming techniques and how this will help us in growing into the future, into the future of India, also the globally, how India is going to play a big and huge role in the farming industry in coming future. And we all witnessed in many areas today. Also we are also as an Indian growing very fast, and we see the growth in the technology and also other aspects as well, right? I have been working in India for 15 years, and also I have asked, giving my little bit brief about myself. I've been asked to lead a company here, which we acquired few years ago. Then that's the reason I debuted here. But being an Indian, always proud to be back in India anytime. Okay, so I am working as a global product manager in Signify Innovations, formerly known as Philips Lighting. I think some of you has visited the Philips showroom in Hyderabad. I glad that I understood you had a very good experience there. Those systems are the ones which we work in day-to-day life. Okay, so for today's topic is more of farming. It's nothing related to lighting, and also how this farming is going to help us in the agricultural revolution and evolution. So yeah, so farming evolution is it is not today, right? So when we look at the history without farming, without food, nobody can live, right? So my kids are studying the very old ancient farming techniques now, which is not there in Indian social studies today. My daughter is studying year 7 in UK. They have very ancient farming techniques, which is comes from Romans and also Catholics, also Iron Age, Stone Age. Also, yesterday I learned about Aztec. Is one of the community who lived in central Mexico for a couple of years. It's only 200 years, but they have created a huge tech in those areas, which is in 1470s and 1470s, between 1580 and 1600 they lived, but they have created a huge difference in the farming, the way they do it in those days, which is Aztec. Okay, if you want to search it, you can search. It's a huge. I learned yesterday from my daughter about how they did a farming technology, right? So, and we are not going to talk about those, but from those days onwards, the sustainability is very very important, right? So whenever any farming, any practices starts, it starts with the sustainability. So what is sustainability is all about, means we are not doing any harm to the nature, and the nature is giving whatever the nature is having. For example, a soil or a biodiversified soil, or air, or light. Those things are very very important before we do anything harm in the farming techniques. So that's where the sustainability is very very important. Even though the technology evolved huge, if we are using technology also, the sustainability is very important, and making sure that we are doing it in a right way, so we are not harming any environmental, we are not damaging any environment. So that's the reason I kept sustainability as a first topic, and to discuss about farming. Then next is the economical impact, right? So the biggest difference which creates is the economic impact. So where it have an economical impact is in the production, as well as the techniques which they use in the though in the forestry and the fishing activities. When they do fishing, is that, and then after farm production, how are we going to use this produced crop into a distribution, like textile, or example, or in the factories, or in the processing of the food, are those items, and then storage of the food, appealing and food storage and beverage of sales, and then serviceability and the manufacturing is the third topic. So how the economical impact is going to be happening on the smart farming with the agriculture which we use. So today I remember the economical impact is huge, in the huge, when there is a up and downs in the farming, right? So I think a year ago, when I came here in UK, we used to buy 10 kg of rice, the eat whatever we eat today, Masuri, if you say, we used to buy for 15 pounds, which is around 1500 rupees in India. And now we are buying the same one for 22 pounds, which is 2200 rupees. The difference is, from that to this, is India stopped exporting rice to other countries. They decreased by 6 to 8% of export because of local consumption. So because of that increase, we are seeing the hype in the in the price, and also seeing the difference in the overall economical impact, which impacted, for me at least, it impacted 6 to 8% of rise in my monthly expenses. So the impact is going to be huge when we look at the economical conditions of every farming techniques which we use. And then the next topic is about environmental impact. Okay, sustainability is one thing, and also the third important topic is the environmental impact. Right. So the environmental impact is going to be like greenhouse emissions, the COT emissions, and accountability of reducing this global COT emissions, and then how when we are using the smart agriculture or a smart farming, how are we going to use the land, how are we going to cultivate the land into a different aspects of it. Also, how are we going to use the water? Is it going to be a fresh water, or it is going to be processed water? How are we going to optimize the water resources to use the smart farming techniques? And then, are we going to generate any pollution, right? So water pollutions out of these, out of the usage of smart farming techniques. Also, the biodiversification of loss or gain, right? So we I must have witnessed, once I started looking at understanding about this smart farming. I saw a couple of videos where in different countries like Thailand or Indonesia, or in even in fact in China, they do farming with the animals. They do farming with how to retain the water, how to retain the fresh water within their agricultural land. So those techniques are very very important also to consume, to, even though using smart farming techniques, so also using biodiversifying of those aspects are very very important. With those we can retain the soil, we can reduce the water pollution, and also the consumption of pesticides also will be reduced. So when we are using animals or biomass related aspects within the farming, we can definitely use the reduction of the pesticides, and those things we can definitely see. And then the security is a big aspect of it, which is not about technical security, what we say, the cloud security, or the identity management related aspect security, the data diversification, not those aspects. It is a security of securing the availability of the food, securing the availability, stabilizing the food, utilization of the food, how it is produced from the agriculture till it is happening supply and demand, right? So this is very very important. So if this is not taken care by the government or by the agriculture administration, then this is going to create a huge impact, huge problem within the countries when we are looking at it. So it is not that increasing the production of the crop is one, and then at the same time balancing it with that in the demand and supply is another thing. We might have noticed sometimes tomato, onion, or some specific crop price will go up huge, and at the same time it drops like that. So that is what the food security which I'm talking about. So it is an optimal utilization of the food which is produced and delivered to a right market at the right time. It's very very important. Okay, so that's being said. So that's the background of evolution of farming, which we have looked at it in a short span. The four pillars here, the evolution of farming is sustainability, environment, and then environmental sustainability, using of the techniques, and the security. Those are the 4 pillars of farming evolution, which I could find out. Any questions? You can type in, or you can ask me. You can pause me in between. It won't be good if I'm only talking, right? Yeah. So, Raghu, if you see any questions in between, just let me know so that we can answer in between.
Yeah, definitely we'll see that.
Yeah. Okay. Thank you. Yeah. Yeah. So then this is one 6 pillar of smart farming, which will increase, which will be using a technology and the utilization of how we optimize the crops and yields, reduce the waste, and at the same time improving the overall efficiency of farming. Right. So the biggest evolution, which is the development is happening, is sensing technology today, right? So in 2015, 2016, when I started looking at IoT industry, there were a lot of sensors came out, and then the developments of sensors are happening in a huge way today. So those are talking about temperature sensors, to maintain a right temperature conditions within a room or within the closed environment, also within the soil, also in that area where the farms are going to grow. So those are connected to different communication devices, and those communication devices are going to talk to cloud and then do all the manipulations in the background. So the second thing is the applications and software applications, how they are, how the developments are happening in those, in the applications, so that we can utilize them in a right way to have a to have a crop, to have a good crop yield, and then reduce the damage to the crops. Then the third is systems, how we build the systems with the sensors and the software, and using those sensors communicating back to different software systems, software pieces, so that they talk each other and integrate each other and give a right information at the right time to the farmers, so that they can take a decision saying increasing the water, decreasing the water to the crop, or do a pesticides in that area in the crops and things like that. So then positioning technology, telematics. So telematics, positioning and technology is more of where you have, where the actual sensors are going to be placed in a different locations or different places. So that is what it is talking about. And then hardware and software systems, right? It's 3 and 5 is more related to interconnected each other. One is looking at the communication areas, say example cellular or Bluetooth devices, or Wi-Fi devices, or LAN devices. We will talk more deeper into it in the later sessions today or tomorrow. And what is talking about in the 5 is hardware and software systems. The availability of hardware and software today is not easy to all the farmers, which we look at, which we see in India, also outside. But the utilization and making that availability to the farmers, so that they can increase their overall efficiency, right? And then the last but not the least is data analytics and the solutions, right? So today many things happens with the data analytics, right? So that is where I told the simple example of 5 to 6% of reduction of supply to outside India created a big impact, uh, big within India and also outside India, right? So they analyzed that, okay, if they are exporting the rice to outside India for those many months, then the Indian community will not have will have to suffer. So that's the reason Indian government took a decision saying they have to reduce the supply in the exports. Sorry. So now we'll go more deeper into a technology using in the agriculture, right? So we talked about operational efficiency in the previous slide. What is increasing the efficiency? Operational efficiency is nothing but it is not only availability of technology to the farmers or to the farming industry. It is also utilizing and allocating the right resources at the right place, right? So you see the picture on the left, on the right side, right? So there is a building, and the whole building is with a green, with the green farming. They have used some type of farming, and then it is completely green, right? And at the back you see a buildings, huge buildings which are producing a lot of CO2 emissions, and then that is coming here, and then it is balancing out. So that's where the balance is required. When you have when when there is when there is disbalance, then it is going to be a big trouble, and damage to the environment, right? That's where the operational efficiency utilization comes into picture. And how this data utilization is going to happen is with the software and communication, with the cloud environment, how this balance is going to go on. And then the sustainable resource management. So so how the promotion of environmental damage, and then conservating of utilization of the water, utilization of the chemical usage, and balancing these three things to the sustainable environmental, picture is the key to a complete smart farming, I would say. Yes. So then the technologies which are getting evolved in the smart farming techniques, right? So today, IoT for real time monitoring. Okay, so there are many companies which are using techniques, the sensors which can use for the soil and crop conditions, crop management, and then enabling the farmers to help and then optimize the crop with the optimize the growth. Growth is the real time monitoring of the sensors which is used. um, so I have a couple of examples in the real-time monitoring, which which is used today in different parts of India, also in every godowns which they store the food and store the farmed crops, right? So in every go down which they store the crops, they use these real-time monitoring systems within those areas, and then do optimize those things. So optimize the supply. So if you know so we all know every crop will take 3 to 4 months. Sometimes some crops will take 6 months of the crop of the to get the yield, right? So but every time we go to a shop and we can buy things, uh, even though the crop comes only 6 months once, we can buy things over the year. So how that is happening? That is happening not only storing, also balancing the food security which we talked, right? So, and then precision with agriculture sensors. So what is it precision? Is like where they have to put the fertilizers, when they need to put the fertilizers, how they can reduce the input costs to the farming, also how they can get the right yield at the right time. So I know for mirchi, for example, for mirchi, they have to do multiple times fertilizers, but the time when they put the fertilizer is very very important. Thus, that is going to come from a different sensors which they can use in the field, so that the sensors can trigger, okay, this is the right time, you are going to get the insects, or you are going to, if the crop is going to get attacked by insects or something. So that's where the fertilizer, they can go and then do fertilizer again. So these are most of them are sensors sending information to a software systems, and software systems are doing a data processing by using data analytics or some kind of algorithms. You can name it as a machine learning algorithms in the behind, with the previous experience of those machines, and then triggering. It's not only the previous experience, it's also environment, water conditions, temperature conditions, rain, everything is included, because there are multiple factors in the data which are variables in this case. So those data are feed into the software systems, and they are giving a right precision information, so that the farmers can take action into it. And then we have seen also a drone technology is becoming modernizing more and more, doing aerial surveys. That could be one thing. Also helping identify issues for farmers. Example, infections of the crops. Also efficient management of the water spill, or fertilizer spill, or those kind of things. So the farmer can come and then see a crop at one end or two ends, or maybe he can walk around and see. But if anything is running behind, not visible, which is not seen by the farmer, which is overlooked at it, then that's going to cause a big problem for the whole crop. So with this drone technology, by doing an aerial survey or taking a video or a photographs, analyzing those by the software tools, by the software systems, is becoming more important in the modern days, coming future. Yeah, for all these things is very very important is the financial accessibility of technology, right? So the financial aspects is one, and the second thing is training and support initiatives. So today we are lagging in these two big items. Financial aspects are because we all know that farmers doesn't make huge money, right? So if if those are all paid by the technology, and the technology needs to be paid, then it is a big problem for them to go and then do investments. So that's the reason the company which I am working is moved from farming to a different area of where the money is. Okay, so but still we wanted to go back to the farming, but there is no funding to do the investments in the farming. So that's where, and the money comes out from farming is less for for a stakeholders or investors to look at it in the farming. So that is a big problem today, I see that. But from the government initiatives, the lot of subsidies are happening in this area to do spread, and also to increase the yield within India, and also to grow into the farming industry on a wider spread adaptations. Okay, and then training and support. So most of the times all the farmers has an access to the technology, but they don't know how to use the technology. That means the right training, right tools, right information, right programs are required. Make their knowledge gaps, and then understand and make them understand to use the technology, so that they can utilize the technologies in a nicer way to increase and maximize the benefits of the farming technologies which are used. Okay, so the next topic is about future developments, the areas of developments what we can look at in the farming, in the farming itself, right? So yeah, so there are many prospects which when I was researching about this, the what are the areas which are still required in the future developments and future areas, right? So these are the list of things which came out, right? You might have hearing about hydroponics and also vertical farming is becoming more famous these days. Nowadays, even I hear in a two-bedroom apartment or a one-bedroom flat also, people are doing vertical farming and hydroponics. In a small area, they can build a vertical farming farm and then hydroponics by using special techniques of UV lights, the ultraviolet lights, and within their home they can produce many crops by using the technology, right? So as a lighting industry, we also supply ultraviolet lights to the farms, and then they grow farms. Also, we do in the agricultural farming is a big industry which we also do. Maybe tomorrow I will show some examples of how the agricultural farming happens in the real life. Also, aqua farming happens in the real environment, in the real today. In some of the videos also we can see tomorrow, right? So these are the different prospects areas. Then smart green evolution or revolution, right? So this is about doing farming in a two-step approach. So the agri farming is happening in the two-step approach. How this happens is on the poultry, this can be used also in the animal farming also, this can be used. The green revolution can be used in these two areas of farming. High of high yeah So high precision farming is nothing but optimizing the farming techniques by using the precision techniques. Like sensors are giving important inputs to the environment, also water, also air. Those are giving inputs, and then the farming is going to be used in the precision. So these two are combined together is the high precision farming, is my understanding, right? Smart green home, and then internet of food, agricultural drones we discussed a little bit, and then smart phenotyping is also more of precision farming. So these are the different prospects. These are areas still a lot of research is happening in the background, and these areas are to be grown and then made utilized in the future. So now we move on to the different applications of farming and farming techniques. Raghu, do you have any questions in the?
No. So one person has been mentioned, let's say Dr. Uma Patel.
Yeah.
She has completed a PhD in IoT-based remote sensing system for smart farming, and now she is looking for postdoc opportunity and funding. She's asking the questions related to postdoc opportunity and funding.
Okay. Sure, I can answer that maybe later. Yeah. Okay. Yes, so the more techniques and the related applications we will see. Okay, so you can see a picture with many dots and also many items. We'll go slowly into one of those items and then see how those are getting benefited into farming, into the farming industry, and the applications of it. So we discussed a little bit about data-driven farming practices earlier. So how these data analytics and the tools which are going to be used are helping the farmers and farming practices. All right. So here. I see compared to Indian environment, the lot of technology is already utilized in outside India today because of the only reason is funding. The funding to the farmers outside India is given as a huge. So far, it is given. It's given and encourage the farmers to do a lot of to utilize a lot of farming techniques to do the farming. So I remember visiting a farmhouse recently in UK. The farming, the wife and husband, they are doing farming from past 30 years. They do farming for around 30 acres of farming. They grow barley and one more crop. I don't remember exactly. I think it is turpin. Yeah. So which is more of beetroot. It's a kind of beetroot or those. That is, these are the two crops they do. Here in UK, only they can do farming from March till August or September. March to September is the time where the sun comes out. The rest of the time is it will be the temperature will be between -3 to 10 degrees maximum. So within -3 to 10 degrees, no crop can grow. So the ideal time to do farming is between March to August or September maximum. So they have only time 6 months to do anything what they wanted to do in the field. Right. So, but rather in India, we have sun for the whole 12 months. We can do wonders there, but only thing is we are not utilizing the innovation and the advanced technologies in the right way to do right things. So the family which I visited after, okay, so they do 30 acres. They use all the technology, all tools, whatever is required, they use it. They themselves do do complete farming. You name everything is done by those two people, nothing else, with the tools and machines, tractors, everything. Right. So they have a complete underground water irrigation system, which is there for the whole 30 acres, which is completely sensor based, and the sensors detects the water level, moisture level in the water, in the yield, in the soil, and those sensors automatically triggers whether they have to give a water or not. So, and then planting also happens in a very precision manner. When they are using barley plantation, they generally do it in the February March time. Barley plantation, when they are doing the plantation, the precision between one plant to the next plant is exactly counted, and between these two they do a cropping of other crops. Okay, and then fertilization is another very important thing which they use it, but very less fertilization is used here. They use more of organic fertilizing. Those organic fertilizing is completely comes from the government, and also the complete crop is sold to a government with a price. The price is decided by the government. These particular aspects, still we are in the development states in India, and maybe many, if you are following the government of India, they are doing and stabilizing these aspects big time in India. So I see the data driven farming practices are getting into India, and we are going to utilize these and then make real efficient farming practices in the near future. And then the innovation and technology applications. There are many companies which are already there in India with the sensors, drones, and IoT real-time based monitoring applications. Also, they also, those companies are working on improving the soil conditions, and timely production, timely crop cutting, and to improve the productivity and the sustainability of the crops. So those are also happening in India. Recently, I came across one company in Bangalore. It's a startup based company. They are using a satellite based sensors, which comes with a very low price, and those sensors are kept in for monitoring the soil and yield testing. All right. So, and then the last one is a sustainable resource management. Right. So this is, you can see a tablet or something which is pointed to a crop, right? So there are many startups which are looking at crop and the items, and they, whether it is the right time to cut or right time to take it out, or still needs to be kept. So those kind of things can be done. Also, whether water resources are required for the crop, or any other resources are required to crop before taking it out. So um, yeah, so here is IoT sensors and the technologies which used in the farming. So predominantly there are three areas where it is required to be developed in a huge manner: the resource optimization, and predictive analytics, and then collecting the data in the real time. Right. So resource optimization is about usage of resources optimally. It's very simple, straightforward, but it is very difficult when we are looking at a huge in a huge countries like India, right? So we have a lot of water resources, okay, and the lot of those resources are getting wasted so much. And also the waste management is another thing which is not utilized properly and not converted in a right way to enhance the sustainability. Also the nutrients which are there in the soil which are not utilized in the right way today. So the resource optimization is one huge important topic which needs to be addressed as a whole farming techniques. We will see how we can look at these optimization techniques in the later session tomorrow. And then real-time data collection, data gathering, and those IoT devices are giving a real-time information from the field, and those information how that can be fed into different systems like monitoring systems and monitoring systems. Once the monitoring system got that information, and then how that can be utilized, and then send it back to farmers so that they utilize it in a right way to get the optimal and better yields. Okay, the predictive analytics is about thinking about uh, historical data of different different inputs and different forecasts, different trends, and different usage of financial related aspects. I mean, different needs of the country, right? So different states might have a different needs at different times. So all these information is going to come from the predictive analytics, and those predictive analytics are going to be used by the different organizations within the country, and they develop this in within the countries, and then move on to do yeah revolutionizing the farming operations. Okay, so when we are looking at the real-time information and the real-time information, real-time data, optimization of these three coming from different inputs. But the biggest problem I see today is every company who are working in the smart agricultural industry, they are working in their own silos. So there is no industry which is looking at, there is no company or no authorization or a government looking at holistically on a very large scale to see this information coming from different software systems and optimize those information to the better needs. For example, a simple case study which I read recently, right? So every so there are companies who looks at the soil and their water resources and their agricultural inputs. Depending on that, they suggest the crop. Okay, so for example, I remember in my childhood days, near my house, um, near our near our town, there are lot of sugarcane crops used to be there. Okay, so sugarcane needs certain resources, uh, certain yield, and certain soil conditions to grow sugarcane. Also, at the same time, sugarcane needs, after taking out the crop, it needs to go to a factories, right, to produce sugar or to produce whatever the sugar related products. Okay, so that is where the company, the olden days, what government has done is, wherever there is a sugar cane resources, they kept the sugar factories so that the farmers can grow those and then sell to a sugar factory to make money. But in the modern days, what is happening, those are going away, and the companies like private organizations, private companies, because of a lot of industrial revolution, they are suggesting the crops, what the farmer needs to do so that it is good to the good to that environment and good for his own profitabilities, right? If that happens continuously over the period of 10 years, 20 years, 30 years, the farmer is going to do same crop or a different crop which is suggested by that company all the time. So what happens? The balance and the food security is going to be imbalanced, which we discussed. Okay, so that is a big problem which I see if every company is working in silos. So data analytics for informed decision and decision making. Okay, so today this industry is not matured enough. So there is nothing, there is no huge data available to do any analytics or to run any analytics today. Okay, so at the same time, utilizing of the optimal resources for the data or the cloud is also very big topic, which is still a gray area. Nobody has no knowledge on this utilization today. And mostly all the decision making algorithms, decision making problems are there only in the retail industry today. For example, example companies are like Amazon or Flipkart, or those kind of companies are using these data analytical frameworks today in a huge manner, but not into farming technology, farming techniques or anything, right? So diverse data resources is also today. So this is also another big black black hole, I would say. So different companies are working on different IoT devices and their own weather forecasting devices, their own soil sensors, their own analytical frameworks, which are working on silos, and there is no integration, there is no collaboration today happening at one level. So that these two are going to be a huge, going to change the whole smart farming industry into a different era. Yeah. So the future of smart farming, it is going to be a trendy. Definitely, it is going to be trendy, and there is a lot of potential in the smart farming in the future. At least, otherwise, this is going to have a big future industry. Whoever we count on, they can definitely get into this industry and then start and then make a big career out of it. So trends shaping the future of agriculture, right? So the advancements in the farming, okay, the usage of AI engines and IoT devices, the usage of big data, which is coming from different sensor informations, and making them together into a framework, optimize those framework and making it enabling a huge enhanced productivity of the farming is definitely going to happen. We see that it's not far, it is going to happen in the next decade or so. And then sustainable agricultural practices, the usage of sustainable agricultural practices are very important. We should not forget about the sustainable techniques, sustainability to be used in the farming techniques, and the urban agricultural growth, the different growth, so that you can see the picture behind. These are grown uh, in a small go down kind of thing, which is open to the open, and then so different carbon footprints, and then these are produced fresh, also transported fresh to a country, to utilized by the people. So the role of sustainability in farming is going to be with three steps. It can up, can come only with three steps. One is the resource optimization, and then chemical usage, the reduction of chemical usage, which will only come by using a right tools and right techniques in the farming. Otherwise, they utilize the more fertilizers, the more pesticides, which will decrease the environment, which will make the environment to be more damaged, which is not sustainable solution. And then a biodiversification, which we discussed in the earlier slides. The sustainable practices only can make the biodiversification of systems. That only keeps the agricultural long-term agricultural practices. Yeah. Okay. So investments and opportunities, right? So the major investments can be in the emerging markets, also the technology investments, also sustainability driven, and the funding aspects of it. Okay. So I wanted to cover a little bit on this IoT devices. Now, any other questions? Raghu, any questions? Okay. Yeah. Can you see my screen again? Back in the full presentation mode?
Yes, sir.
Okay. Okay. So in the most of the IoT devices, okay, so this is the IoT spectrum. I'm sure most of the communication electronics and communications teams might have seen this spectrum of usage. So today, we will discuss more tomorrow on which spectrum is used in a different technologies and different in a different application areas. But today I will just give you a glimpse of the whole spectrum, and then tomorrow we'll go more deeper into a spectrum and application areas and things like that. Okay. So the proximity is 0 to 10 centimeters used, so which are more of NFC devices or RFID devices. Okay, right. So if you look at access cards today, or the payment gateways, the NFC chips inside the credit card, debit cards, so those are more of RFID, more of NFC, because NFC needs a more security. NFC can be more secure item, and RFID is also can be. These are the proximity related aspects. Okay, so these can be 0 to 10 centimeters, so which is very low range wireless communication is used. So the second is the wireless personal area network. Okay, so which is WPAN, which could be from 10 to 100 meters distance. Okay, this is the range. This is the application area where today most of all the IoT devices are running. So you name Bluetooth, which is in the same wireless personal area network, and then Zigbee, low power WAN, okay, and then ZWAV, and then wireless HART. There are 6LoWPAN. I'm sure maybe some of you might have heard about it, and then other companies like Enocean and then plus more. These are also more works in between 0 to 100 meters range. So the security mechanisms of proximity and wireless PAN are different. So in the NFC, usually the security happens when before you take a credit card and then give it to a different NFC device, which is not a payment device. Then it will not even authenticate it. Okay, it will not even exchange any data between these two devices. right? So that's where the security comes in picture. And even WPAN, so the Bluetooth or Zigbee, this is becoming more of open communication today to these days. uh, why do I say open communication? It's because of more devices coming into this range, which is in the 2.4 gigahertz communication range. So those devices are coming more and more. That's where becoming more easier to do authentication, more easier to do any communication. So, but before you communicate this device, you need to be within the range. Also, you need to be pairing them before starting or before talking to that device. Okay, so that's how it works. Wireless LAN, okay, wireless local area network, so which is our Wi-Fi, which runs here 802.11a or 802.11af wider spectrum, and also 802.11p, and then there are other standards in it, which works between 100 to 1000 meters. This is where most of the smart IoT devices are running, which we are talking about smart sensors. Most of the smart sensors are on this range, okay, which are sub gigahertz, and also low data rate between these two devices, and also low, and they need a proper authentication before they talk to anybody. And then wireless neighboring network, which is more of Wi-Fi, which is a just developing communication technology. And then Zigbee NAN is also a developing communication technology, which is going to be revolutionizing in the future. The cost of these devices today is high, and also we are thinking that Wi-Fi is going to be next revolutionary, like a cellular devices, smartphones in the near future. So that's where there we can use 2.4 gigahertz to talk to a long distance, basically. Okay, and cellular, you all know 2G, 3G, 4G, LTE, Cat M1, Cat M, Cat, different LTE bands, and then the 5G is no more future. 5G is there in most of our mobile phones today, but not extensively used 5G today still. And then there are other technologies like low power wide area networks called Sigfox, LoRa, and then other technologies more. Yeah, so we will deep dive into these areas tomorrow more, and how we can prepare and then make our IoT devices more smarter into it. Also, we'll touch upon a little bit on cloud-based systems also tomorrow. The architectures of cloud-based systems, how those are happening. Also, looking at connecting these smart sensors into the IoT world. Yeah, so that's all I have, ma'am, today.
Very good evening, one and all. So do you have any queries out there? Just raise your hand, or else just post your questions in our message box.
Hello, sir.
Yes, we can hear you, sir.
Sir, I am Dravyam from Anna University, Tiruchirappalli.
Yes, sir.
I'm doing my PhD in deep learning using precision agriculture. One
Yes, sir.
of my novelty is plan to collect microclimate data using IoT devices of a particular agriculture land for predicting the crop yield.
Okay.
There are different types of agriculture, types of land, but I need to collect the microclimate data of a particular agriculture land, which is on a plain, which is not like mountain or anything else. What is the procedure to collect the microclimate data using IoT device? When I collect using neutral stage, or I place the IoT device entire agriculture land, sir?
So what is your exact application? Maybe can you give a little bit more? So is it on the microclimate for crop, or for harvesting, or planting, or for pesticide related aspects? So these are different aspects, right? When you are looking at microclimate data. So yeah, so which is a very good input, which is very important input, which needed for the management of the crop. Okay, but when you are looking at microclimate data, at the same time you are looking at the crop suitability is one aspect. Second is another thing. When you are doing harvesting, it's a different input need. When you are going to do pesticide or for disease management is another aspect. When you are going to look at soil is another aspect. Climate change is another aspect. So your application, whichever you are to look at it, you have to look at all these aspects, and your microclimate data is going to be varying depending on your application.
Yes, sir. Yes, sir. Sorry for the disturbance.
Right?
Yes, sir. Yes, sir. Yes, sir. Sir, I plan to I planned a crop yield prediction using deep learning, using visual images. That visual images is not enough to predict the crop yield. That's why I plan to incorporate microclimate data of a particular agriculture land, so that the visual images plus microclimate data will help the crop yield prediction. I planned that manner, sir.
Okay. Yeah. So maybe we can discuss separately, in more deeper understanding, what is your application information, and then how I can help you out. Maybe
Yes,
even
yes.
I might need more study on this, because
Okay.
this area
Okay.
I never looked at it. Yeah, microclimates is a new
Okay.
item, new thing to me. Yeah.
Sir, please
Any other?
share your mail ID, sir, for a fruitful discussion in future.
Yes, sure. So I will share my presentation at the end of tomorrow. Then you
Yes, sir.
can get
Yes.
my email ID in the presentation. We can talk. Yeah.
Okay, sir. Thank you so much. Thank you so much.
Sure. Yeah. Any other questions?
Hello. May I audible, sir?
Yes, ma'am. Yes, Uma, ma'am. You are
Actually, I
audible.
have completed my PhD in the same subject, IoT-based remote sensing system for smart farming. Now I am looking for postdoc opportunity in India and funding also. Is there any, I just wanted information regarding this.
Sure, ma'am. I can get you connected to some local Indian-based companies.
Yeah.
Also, maybe some people who are working in this area. Maybe that could help you. Yeah.
Thank you, sir.
Okay, then. Yeah. Thank you, Raghu. Thank you, ma'am. Thank you for giving me this opportunity. And it was a nice session. And then I learned a lot. Thank you. Have a good day. Bye.
Thank you so much, sir.
Shreya, please close it.
All right.
So dear all, please complete this poll. Thank you. Dear all, next session will be started at 8 p.m. sharp today. Please don't leave the room. I request everyone, please uh, complete this poll. In meantime, one more session is there, 8 to 9:30.
visible, sir?
Yes, sir. It's
Yeah. Thanks to the coordinator, Mr. T. Raghavendra Gupta, sir, for inviting me to deliver a lecture on this machine learning and computer vision in smart farming. As of now, our the governments are also very keenly working on this particular domain to help the farmers in the agriculture domain. So I will try to give my best in this lecture, machine learning and computer vision in smart farming. So before going to this machine learning and computer vision, I would like to give some knowledge on artificial intelligence. What exactly is artificial intelligence? Because both machine learning and computer vision are the sub branches or subdomains of artificial intelligence. So
ఉన్నారా సార్ లైన్ లో?
yes, sir.
ఓకే సార్, ఓకే సార్. లేదు, ఉన్నారా లేదా అని. సార్
Yeah. Yeah. So I will give you some brief introduction about artificial intelligence. What exactly is artificial intelligence and how it is used in various domains like agriculture, healthcare, financial, etc., etc. Okay. So we need some basic understanding about artificial intelligence. So here I am providing a picture. Consists a girl is dancing by wearing the headset in the ground or in the farm. So the girl is deeply enjoying and humming and dancing. So suddenly in the lawn, an unwanted friend entered. So the unwanted friend is a snake. So the unwanted friend tries to disturb the girl. Assume yourself is a girl, maybe a boy or girl, or a male or female. Okay, you are deeply enjoying the music in your own lawn. An unwanted friend entered and it is trying to wish you, to disturb you. It is trying to disturb you. Okay, so initially it failed to disturb you. So at a certain point of time, it succeeded, disturbed you. So suddenly you opened your eyes. So you observed a snake. So how you will react? So for understanding sake, there is a strategy. The strategy is called KISS strategy. So here we are trying to understanding how a human being will behave whenever he or she observes some unwanted friends. So here in the KISS strategy, the first two letters K, kills. If you are a brave person, you are trying to kill it. So if you try to understand the situation, so in your body, so which part observed the unwanted friend? So your eyes observed the unwanted friend. So immediately, which part reacted? So if you consider the scenario, so immediately your hands will start working. Exactly? No. So again, your eyes only will react because you are a brave person. You are trying to kill it means you cannot kill it with the hands. So here you need some tools to kill, maybe a stone or a wood material, a stick is required. So here eyes observed, eyes passes the signal to the brain, brain again send the signal to eyes, and to legs, and if you find the stick, your hands are working. Okay, so this is happen when you are a brave person. So if you are a brave person, you can kill it. Then the next letter S, shouts. You are not a brave person. Okay, so which part again you observed in your body? Eyes are observed. So eyes send the signal to brain. So what happened? The signal is stopped. Signal is sorry. The signal is passed to another part in the body. What is that? The mouth. Your mouth is working now. Means you are scared about the snake, so you will shouts. Please help me. Okay. So here, if you understand the scenario, so your eyes are observed, pass the signal to the brain sends the signal to the mouth. Mouth starts working in this case. The next letter S. So in this case also, eyes observed, sends the signals to brain. Brain stops working for few seconds, not completely, working for few seconds. And once you come out from that shock, okay, you may realize. So you may exhibit any one of this behavior, means shouts or run away, or you are trying to escape this situation. Okay. So here, what is happening? You are a human being. You are trying to responding or exhibiting some behaviors. So the first behavior is kills. If you are a bravery person, so you try to kill it. In the second case, so you are not a bravery, so you are a coward person, so you are asking for a help. The third case, for a few seconds, your brain stops working. Later, it will realize. So here, you are a human being. You have some sensitization. Okay, so you are exhibiting the respective behavior depends on your nature. Now, this unwanted friend is replaced. Oh, sorry, the girl is replaced with a robot. The girl is replaced with a robot. Okay. Now, robot is enjoying what you did the same way. The robot is enjoying the music by wearing the headset. Okay. It is also deeply enjoying. Okay. So the unwanted friend entered. So how a robot will respond? So robot doesn't care about whether it is a snake or lion or tiger, any harmful animal. Entered into the situation, it doesn't bother because it is not having the sensitization like a human being, because it is programmed by humans. So if you programmed this robot for this situation, it may react. So what is happening here? You are trying to giving your own intelligence, your knowledge to this human robot. The humans are giving intelligence to the robots. Okay. So based on this intelligence and knowledge, available knowledge, so the robot will respond with respect to the scenario. Okay. Now, if the robot is completely programmed or some percentage is programmed, that is the situation we need to understand. If it is completely programmed, it may behave, it may exhibit different behaviors as per your program. Depends on the situations. Okay. Now, here, is it possible to give the complete knowledge, or it's nothing but we are here, we need to transfer the complete intelligence of a human being to this robot. So it is not possible all the times. In some cases, it may be possible. Some cases, it may not be possible. So here you need to, so like this. So how a human being responds for the scenario. So you need to identify the different scenarios and you need to exhibit the knowledge. Okay. So this is about the artificial intelligence. So here we are trying to making a machine do things like a human being. Now we are jumping into the flavors of this artificial intelligence, machine learning, and computer vision. How these are useful in smart farming. So these are the key topics that I'm going to cover in this session, in this 1 hour, 1.5 hour session. So importance of smart farming. So why smart farming is required. So today we are listening the word smart everywhere, smart cities, smart agriculture, smart vehicles, so smart electronic gadgets, etc., etc. Okay. So what is smart, what kind of smartness is existed in the agriculture. We'll try to understand. Okay. And in this process, the role of machine learning and computer vision, how these two subdomains of artificial intelligence will help in smart farming. And in addition to this, some advanced techniques so that we can utilize in smart farming, and some real world applications, and what are the different challenges that are involved in this smart farming. So like this. Okay. So here we need to, so these are the only three behaviors we are exhibiting. No. So that depends on the person. So there are multiple behaviors. So here I try to show few of the behaviors. Similarly, in case of in any application, you need to understand what is the business problem, business model problem. You need to understand. Okay. So here our problem is smart farming. Okay. So here, so if you try to understand the statistics, okay, so as part of the smart farming across the global need, global food demand expected to rise by 80% by 2050. Okay, so we are in completely depending on this agriculture and its related products. Okay, so need for sustainable and efficient agriculture practice. So when the demand is increasing, we need to supply. So if both are not satisfying, so there would be a food crisis will happen. So we need to meet this 80% of 80%. So 20 by 2050, 80% of the agriculture products are having demand in the market. So how to achieve this 80% demand? Okay, how to fulfill this need for sustainable and efficient agriculture practices? So what are the traditional agriculture practices? So to achieve this 80% demand, okay, what are the smart farming techniques we can utilize to increase the production of agriculture products? Okay. So role of technology in addressing labor shortages, climate change, and resource optimization. So here, the agriculture involves various factors. So the first thing is shortage of labor. Okay, so here in India, particularly in India, we are depending on the labor resources, means the human resources. So if the human resources are not available, so how to overcome? And the climate change. So here, some in some areas in India, so the climate is not predictable. Okay, so how to predict with respect to the soil and the environmental conditions, okay, etc. And resource optimization, how to optimize the available resources. So the same thing is showed in a graphical form. Okay, by 2050, there is a huge demand for agriculture products, 80%. So we need to supply as per the need. So to supply, to overcome this problem, so here some of the machine learning techniques are provided. Okay, so to how to achieve this? Okay, so here one of the application, crop yield prediction. Okay, so here I have shown you 2050. This is not exactly for 2050. Okay, it may happen in 2030 also. It may happen in 2040 also. Okay, so how to predict that? Okay, so this is not static. This is a dynamic. So depends on the population size. So here, so how to identify or how to predict? Okay, what is the crop production today, and what is its expectation in coming days? Okay, similarly, pest and disease detection. Okay, so even in order to provide our yield good crops. Okay, so we need to overcome these problems. These are the inherent problems are existed in agriculture: pest and disease detection. Similarly, soil quality analysis. So here, to get the good crop, so we need to periodically test the soil and its parameters. Similarly, weather prediction. What is the current weather? Okay, so how it should be for next 1 week, next 1 month, next 1 year, like this. Okay, so based on that, we can uh, give some good crops. Then livestock health monitoring. So here, we after harvesting, so we need to shift the crop to the various gardens. So there also, okay. So depends on the public demand, what is the stock is available, what is the demand. So this kind of analysis also is possible with machine learning in terms of smart farming. So computer vision. So these are some of the computer vision applications in smart farming. So image-based plant disease detection or identification. So how? So now I'm going to discussing this. This is the first problem I'm going to addressing. Okay, image-based plant disease identification. So how to identify whether the plant is diseased plant or a healthy plant. Okay, so first we need to check regularly. So sometimes it requires every day. So it is not easy to check whether the plant is growing healthy plant or some diseased plant. Okay, so the disease may be started from roots to the leaves. So here we targeted here image based in this session. Then similarly weed detection, like we detected fruit and vegetable grading. So here also we can, so this depends on the size of the fruit. Okay, we can grade the fruits and healthy fruit or diseased fruit or about to disease. Okay, so like this is also possible in today livestock tracking using cameras. So here we can track, okay, what is the present stock and how many days it can be used. Okay, these details can be tracked. Then drone based field monitoring. So here we can check whether the soil, particularly soil, is good or not. Okay, whether it watering is required or not. So such type of information is monitored through this drone based field monitoring, particularly in smart farming. So these are some of the advanced machine learning techniques in smart farming. So we can use. So deep learning for feature extraction. So here, as I told you, here image-based leaf disease detection. So we can use various deep learning methods like convolutional neural networks, okay, recurrent neural networks, etc., vision transformers, etc., etc. So transfer learning for small data sets. So here the greatest problem involved in this smart farming is that so we are lack of data. So in order to do the experiment, from where should we get the data? So it's not available. So in case of image based like computer vision, machine learning, which require these techniques requires a huge amount of data, but we are lacking data. How to get this sufficient amount of data, adequate amount of data is how to get this. So we will produce from the existing data. So we call that is the data augmentation. So here we use some image processing or image pre-processing. So when you are applying image processing or image pre-processing techniques, there is a possibility of data loss. So how to overcome that? Then reinforcement learning for robotic applications. So here local learning is essential. So how to adopt that? Then ensemble models for prediction accuracy. So various ensemble methods like XGBoost techniques, gradient descent techniques, etc., etc. So this can be used in smart farming. Then generative models for synthetic data augmentation. As I told here, so whenever we are having very small amount of data, we need to generate the new data from the existing data only. So that is, so today we have various models, generative AI models to generate the synthetic data. Okay. In addition to this, some advanced computer vision techniques related to image processing. So multispectral and hyperspectral imaging. So we need to understand the image. So here, what we are giving as an input to this deep learning model or machine learning model an image. The image consists of maybe either leaf or root, okay, or the buds. So here we need to understand whether the image is a good quality image or not. So here sometimes we cannot work directly with the RGB images. So initially we will convert the RGB image into grayscale image, and we will apply the various machine learning or computer vision techniques. So based on the obtained results, we will further proceed. We'll do some experimentation. Okay, so here we try to understand the how many bands are there in this input image that is captured from the mobile, etc. etc. That depends. Okay, so we try to understand what type of image means whether the input image is qualitative or not. Some quality information is used for experimentation or not, we are checking. So to do that, these imaging techniques can be helpful. Then semantic segmentation for precise object detection. So here, whenever you are having a good amount of images, okay, so sometimes you cannot work with the means particularly the leaf disease detection. Okay, so the leaf may be 100% healthy, may not 100%. So 1% may be unhealthy. So how to identify that unhealthy part? Because if you identify whether the leaf is healthy or not, depends on that, you can predict some crop. So whether it may give good crop, it may yield good crop or not. Okay. So here we will segment that images. So that is semantic segmentation for precise object detection. So these techniques are particularly helpful in disease detection. And 3D vision for plant structure analysis. So today, so maximum times the researchers are using 2D images. So now slowly we are entering towards the 3D images. We may work with this 3D images also. So there are some techniques to work with that. Real-time edge computing for drones and IoT devices. So here you can work with IoT devices also. So these IoT devices are continuously monitoring like the soil temperature. Similarly, the drones. Then attention mechanism for anomaly detection. So here attention means you can manipulate the data by using some advanced techniques like vision transformers. So what level of required? Okay, so if it is crossing our required limit, okay, so there, so we can identify the anomalies that are existed in the input images. Okay. So these are some of the real world applications, disease prediction with the smartphone apps. So I hope the government units are working on this. Of course, some cases are succeeded, some cases are failed. So due to the unavailability of the data. Okay. So today we will discuss this disease prediction with smartphone apps. Precision irrigation using soil moisture data. Okay. So here, if the soil is good, so we need to find whether what is the soil percentage. That means various parameters like nitrogen, magnesium. Okay, so these we need to. So by looking into that soil, we cannot determine it. Okay, we need to test it. Okay, so here we will test some using some machine learning and deep learning and computer vision techniques. Then automated pest control via drones. Okay, so here depends on the generated images. So the drones itself, they can make some decision. Can be the pest is required or not, based on the current conditions. Okay. Then yield estimation using satellite imagery. Robotic harvesting system. So these are some of the real world applications. So this is the primary application that many researchers are working. So disease prediction. Okay, so in implementation of this, what are the challenges are involved? So limited access to high quality label data. So this is the biggest problem in not only in this agriculture, in almost all fields. Okay, so here to run ML model or deep learning model, or simply we can say artificial intelligence model. So it requires a huge amount of data, but we are not rich in data. So how to get the required amount of data? So to get this required amount of data, we may use some augmentation techniques, image augmentation techniques. So using the image augmentation techniques, so we can generate new images from the existing images. Okay. So then high cost of technology adoption, of course. So when we are going for adopting the advancements, so it is mandatory high cost. Okay. Then integration with the traditional farming methods. Okay. So here in India, it will take time. Okay. In some areas, the farmers are adapting this. Okay. So it is not easy to adopt all the methods in the traditional methods. So how to integrate? We'll try to integrate and variability in environmental conditions. So here, so as we discussed in the earlier slides, the environmental. So it's not easy to predict the environmental conditions when it will rain and when it will sunny. Okay. So when it is windy. Okay. So this it's not easy. It is with respect to the global. It may vary. Then scalability and interoperability issues. So here scalability. So you want to build a large scale system or small scale system. So if you consider the large scale system, what are the resources that are involved in building this system? Like the hardware resources and the type of input data. Okay. And the corresponding software resources. Okay. And the internet facility. So because here if you are trying to adopting this machine learning or deep learning or AI techniques, so you need to think about all this. What is the size of the system? Okay, if it is a large scale system, so it may be expensive. So how to build that such type of large scale system can be useful for a good number of users. Similarly, interoperability. So here, if I talk interoperability, it takes more time. I hope all are technical experts, so you can understand what do mean interoperability. So here, with respect to this agriculture, interoperability is nothing but so depends on the devices that we are using to predict. So maybe like the leaf disease or crop prediction. Okay, environmental conditions. So here, all these are involved in this interoperability issues. So it's not easy to understand this interoperability issues. So one should have a good amount of knowledge on all the techniques. Okay. So now I will discuss for a few minutes on this multi-crop leaf disease detection using deep learning methods. So in this multi-crop leaf disease detection, so how the machine learning techniques are used, particularly the deep learning techniques in this context, I'm going to discuss a few deep learning methods, how these deep learning methods can be implemented on leaf disease detection. Okay, so with respect to that, the problem statement, manual leaf disease detection requires significant resources and expertise. So here, manually, if you want to detect the leaf disease, so if you take 1 acre land, so yeah, if you put some plant, some a crop like tomato or cauliflower or cabbage or potato or some vegetable. Okay, is it easy to detect each and every plant health condition? It's not easy. Manually, if you want to check. Okay, so here whether it is healthy or not diseased. Okay, unhealthy or healthy. So if it is healthy, ultimately it may yield good crop. So if it is not unhealthy, how to make it healthy? If means if it is diseased. So if you are able to detect it at its earlier stages, it's easy to overcome the problem. Okay, so here in the traditional approaches, as of now, in some areas, manual leaf disease detection. So manually, the farmers are checking the plants. So here it takes more time to checking each and every plant and the leaves. Okay. And high costs and human errors impact the reliability of results. Okay. So here it takes, it may be expensive. Okay, so sometimes the human means who are involved in this, I assume that is maybe even though it is unhealthy, may assume it is healthy by looking into the condition of the leaf. Because here, if the leaf is diseased, means if it is 50% spoiled, then we assume the human may assume that it is diseased. Okay, if it is 10% unhealthy, a human being may not assume it is unhealthy. So here this may leads to a wrong prediction of crop. So similarly, need for a robust, automated, and accurate solution leveraging deep learning techniques. So here we need some advancements techniques. Okay, how these advancement techniques will help? Okay, leaves is disease detection using deep learning application can be helpful for farmers to analyze the affected leaves at an early stage, which will in turn aid in the agriculture process. Okay, so if a farmer is able to detect the plant is healthy or not. Okay. If it is unhealthy, if the farmer is able to make a decision at its early stages, he can correct it by giving some pest. Okay. So there, this machine learning or deep learning will help. Okay. So here some of the deep learning techniques like convolution neural network algorithm mainly used for analyzing visual imagery. So by collecting the pictures of the leaf images, okay, so we can work whether the plant is healthy or not. Okay, then CNN model based model will help in differentiating between diseased and unhealthy leaves, which will improve farmers harvest quality. So this is the problem in this problem. So how image processing will help? So image processing for leaf disease detection. So these are the different phases of the image processing in order to detect the leaf disease detection. Okay, so the process starts with the image acquisition. So here he collect the data. Okay, collect the data. So use different types of cameras. So the farmer may use the mobile camera, or some may use the DSLR camera, some pixel cameras. Okay, so here in order to experiment, you need to understand whether the images are qualitative or not. Okay, so if you are able to capture the original information, then it's easy to determine. Okay, so in this process, image acquisition. So during its initial stage, whether image is the image data is captured. Okay, in image acquisition, we will try to capture the original images by using the cameras. Okay, or sometimes so you may have some available data in terms of document form, so you can scan the document form, or you may have some videos. Okay, so you may not have directly the image, so you may have video. From that video you may try to obtain the images. Okay, like frames, dividing the video into different frames. So in this process there is a possibility of data loss. So there is a lot of research involved how to obtain the qualitative image. Okay, so in order, if some losses existed, how to overcome that? Okay, the next stage is image enhancement. So in this step, okay, we try to improve the quality of the image by adjusting its brightness, contrast, and other properties. Okay, so here we try to overcome some noise if it is existed. So here in case of image acquisition, if you are having videos, from the video if you try to obtain some image, there is a possibility of excess information, there is a possibility of less information. So by using some image artifacts, we can enhance the image. Okay, and image restoration. So in this, so we are trying to overcoming the problems like are there any image, okay, whether it look quality or qualitative, okay, or is it original or damaged? So the damage may be like this blurry image, or some noises existed, means some additional information maybe, or some deaths. Okay, so this, okay, so if you identify those things, we can restore the image by using image restore techniques. So the next phase is morphological processing. So in this case, so you can manipulate the image. So here, how image will form pixel by pixel. Okay, so by adjusting these pixel values, or by manipulating these pixel values, okay, you can change the shape of the objects that are involved in the image. Okay, so here you can use some filtering techniques, some image smoothing techniques, and you can extract some features. Okay, so there are many techniques so to filter the noise, okay, to smooth the images. The next stage is segmentation. So here the given input image is divided into various regions that the researcher is interested. Okay, so here the main objective in smart farming is particularly related to this leaf disease detection. So here we are trying to identifying whether the leaf is healthy leaf or diseased leaf. So how to identify that? Okay, so by looking into the leaf, you cannot assume, or you cannot say whether it is a healthy leaf or unhealthy leaf, or a diseased leaf. We need to do some experiments. Okay, so after capturing the image of that leaf, okay, so we will divide that leaf image into different regions. Okay, and we'll collect that region pixel values. Okay, and compare with its original. Means, so there are some threshold values for healthy leaf, unhealthy leaf, and diseased leaf. So we'll try to compare with that. Okay, so by collecting the objects that are presented in the regions. Okay, so this can be achieved using the color that is present, the texture that is present, the shape that is present in the image. Then object recognition. So in this case, how to identify the objects that are present in the image. So I will show you in coming slides. Okay, so here how to identify whether that leaf is healthy, unhealthy, or diseased. Okay, so a simple example. Okay, if the leaf is completely in green color, we can assume that it is a healthy leaf. Okay, some part of the leaf is green, some part of the leaf is yellowish. Okay, so we can assume that is unhealthy. So 80 to 90% is yellow color. Okay, so 10 to 20% is green color. Okay, so we can assume that this is a completely diseased. Or sometimes during winter seasons, we can identify some black spots on the leaves. Okay, so we need to identify that objects. Then representation and description. So this involves representing the objects in an image in a way that it is suitable for further processing or analysis. So here, what is detected here, what is identified here, with this information, can we proceed for further analysis or not? Okay, so as we discussed today here and all the previous stages, okay, that depends on the available color, the shape of the object, or the shape of the healthiness, maybe a green color, yellow color, or some black spots, the black spot size, okay, the depth of the black spot on the leaf, okay, and the texture, and some spatial features. So by using in this, we can collect some relevant information. So this is when you work with RGB. So here you have a color image processing, okay, technique. So here usually we have the input data in RGB images only. So you cannot, sometimes you cannot work directly with the RGB images. So we need to convert these RGB images into grayscale images, and then we can extract the what we discussed here, all these features. Okay. So here you can decide whether you want to work with the color images or a grayscale images. Okay. And in addition to this, so you are carrying a huge amount of data, some image compression techniques. So here, in order to obtain the good quality images, so sometimes we may use image compression techniques also will give some good quality images. Okay. Then deep neural networks. So how these deep neural networks will help in case of leaf disease detection. So I hope you are all aware of these deep neural networks. So a neural network consists of different layers. Input layer. So that is, if you see here, some input layers, and then a hidden layer 1, hidden layer 2, and hidden layer 3, and some output layers. So how can we use this deep neural network for detecting the disease in leaves? Okay. So here what we are giving, we are giving an image as a input. Okay. Now what happens at this input layer? Okay. So once if you give an input image to this input layer. Okay. So here, what do you mean this circle? What do you mean these lines? Okay. Here each circle represents a layer. Okay. So in this input layer, each circle represents a pixel or feature extracted from the image. Okay. If the pixel value or some feature that is researcher interest. Okay. If you want to work with the pixel value, you can work. Or if you want to work with, so from this input image, okay, you can take the numerical values in terms of pixels, or you can use some features. Okay, means that features means so some attributes of interest. Okay, so here we are giving, with respect to our example, we are giving the healthy leaf or unhealthy leaf image or diseased leaf image. Okay, so here what this layer will store. Okay, what this layer will store. Okay, so each circle may store if it is a healthy leaf or unhealthy leaf or a diseased leaf. Okay, it stores the various colors that are presented in the input image. Okay, like red, green, blue. Okay, of course. So that depends on the researcher, not only colors. Okay, if the researcher is interested, the texture that is presented in the input image. Okay, and the edges. How are the edges? Okay, in order to determine the leaf is healthy or diseased. Okay, first we will work on the edges, the leaf edges. Okay, and the picture resolution that is provided in the input image. Okay, so that information is collected in terms of these circles from the input image. It may be either healthy leaf or unhealthy leaf or diseased leaf. So that information is processed to the next layer, that is hidden layer 1. So here hidden layer 1, hidden layer 2, hidden layer 3. So what these hidden layers will do? So what they represent? They are some core processing units of deep neural network. Okay. So each circle each circle represents a neuron in the hidden layer. Okay. So it collects the information, some weights from each input. So that is, so here this circle may be collected pixel, this may be texture, this may be some spatial feature or some attributes of interest. Okay, so for every input there would be some weight. So that weights are collected at each neuron. Okay, and they will sum all this and tries to detect various what we call some non-linearity that is existed in this input information that is collected from the leaves. Okay, so here at each neuron, okay, it will sum all the data that is collected from the images, and this information is passed to the next hidden layer. Okay, so here again it will refine the information from all this. So here every neuron collects the information from each circle of the input layer. What is the circle? One may be pixel value, one may be texture value, one may be spatial feature, one may be shape, one may be so like this. So that depends on the researcher interest. So that would be summed. So for further refinement sake, this information is given to the next hidden layer. This information is furtherly refined and given to. So that depends on the researcher interest. You can build your own deep neural network. Okay. So how it helps in this? Okay. So here it helps to understand what are the complex patterns that are existed in this input image. Okay, so for example, for understanding sake, so the first hidden layer detects some simple edges and textures, some simple edges and textures. The second may identify more complex shapes like the diseased leaf, the black spots. Okay, or we can say that those are lesions in the images. Okay, and the third in hidden layer may identify the disease pattern. Okay, so here how many hidden layers if you want, so that depends on the problem or application. You can design the deep neural network. The deeper the network, the more complex features it can learn. Okay, so here as I told you in the first slide, okay, artificial intelligence. So there the girl is exhibiting three behaviors. One is kills, one is shouts, one is shocks. So similarly here depends on your research interest, how many hidden layers you want. Similarly here how many input features you want to collect. Depends on that you can design. Okay. So here all these connections. So these blue color lines are indicating that all the neurons that are there in the hidden layer are connected one with another. Okay. So through these connections, it carries the weight information from one circle, one neuron to another neuron. Okay. So here, if you see, sometimes we can represent a solid dark line or a simple line. So the solid dark line indicates that the information is means the weightage is more. Okay, so here how to adapt this for the leaf diseases. Okay, so here if the size of the neuron cell and the size of this connection is more thicker, means the weight is more. Okay, so comes to the output layer. So this output layer indicates that the final output of the network. Okay, so here depends on your interest. What you want to produce, whether you want to produce whether it is a healthy leaf or unhealthy leaf or diseased leaf. So here, if you want to decide, okay, so on what basis you are saying whether it is diseased or unhealthy. Okay, so based on the available information, and that is basically comes to image processing, the colors using some color science. Okay, so you may decide whether the leaf is healthy leaf or rust leaf or blight leaf or mosaic virus. So some virus is presented. Okay, so this is so you're using this deep neural networks, you can detect whether the leaf is diseased or healthy. Similarly, VGG16 network. This is also another deep learning model. So here, this is a advanced mechanism. In this advanced mechanism, as you are observing on the image, so here you need to give some input image. So this input image indicates the what is the dimensions. Okay, so 224 by 224 by 3. So these are the dimensions. So this indicates the width, height, and the pixels size. Okay, so here three this three represents like a red, green, blue RGB image. Okay, so here you are working with this color image. Okay, so the next boxes, white color boxes are there. So these white color boxes are called convolutional layers. Okay, these are the core building blocks of the CNN. Okay, so this is 224, 224, and 64. So, so this input image is given to this convolutional layers. So what is happening here? So this convolutional layers filters the images. So what it will filter? So that depends on the researcher interest. Here you can sum all the pixel values that are available. Okay, and it can create a feature map that can be used for further study. Okay, so here the features are like edges feature map from this provided input image. So the feature map may consist some edges or textures or patterns. Okay, so like this. And then after completion of this convolutional layer, so a ReLU network. Okay, so that is these boxes. These boxes. The ReLU means rectified linear unit. So this is an activation function. This activation function is plays a crucial role in order to understand the complex patterns that are existed in the input data. Okay, so here we are working with the images. So what level of complex patterns are existed in this? Okay, so but with respect to our problem called leaf disease detection, so these layers like the convolutional layers or ReLU layers detect various features relevant to the diseases. Okay, so how can we say whether it is a healthy leaf or diseased leaf? So if some information is presented like spots, lesions, discoloration, means different colors. So healthy leaf looks like a green color, a dark green. But if you identify some other than this dark green color, okay, some yellowish color, okay, a red color, okay. So here by looking into this some visual symptoms we can say, okay. Then it is given to the some these red color boxes. So these red color boxes are called max pooling layers. So here what it will do, it will try to understand the various complex data that is involved or existed, okay, from this feature maps. Okay, so it divides the each feature map into the smaller regions. Okay, for understanding sex 2 by 2 pixels. Okay, so I think that if you assume like a tabular form, the first 4 pixels are in one region. Okay, the second 4 pixels are in one region. So like this, it will divide the pixels into different regions. I try to write here. If you assume this is an image. Okay. So the first 2 by 2 means, so this 2 by 2 max pooling. This is one region R1. This is the next square R2. Like it defines the various max pooling regions. Okay, so we try to identify the similarities between these regions, and we'll try to do some further analysis for spatial dimensions from these feature maps. So this may reduce the further problems, like some computational cost may reduce. Okay, uh, and are there the difference is more or less, depends on that. Okay, so how to adapt this for leaf disease detection? Okay, so this max pooling helps the network focus on the most important features. Okay, the most important features. What are the important features? So if you want to identify the spots, the black spots or lesions, okay, what is the depth of the lesion? What is the size of the lesion? Okay, so all this information is collected from this max pooling. Okay, so then the progression layers. So this you can go as you move more deeper into the network. The convolution layers learn increasingly complex and abstract features. Then it is fully connected layers. The next one is blue color. So this blue color layer, light blue color layers. Okay, so after several computations of these convolutional layers, the various feature maps are constructed. Okay, these feature maps are constructed, converted into one-dimensional vector space. Okay, so this one-dimensional vector space is created like a traditional neural network. So here each neuron is connected to all other neurons. Okay, one with another. So how to adapt this to the leaf disease detection? Okay, so here all these layers combine high level features learned by convolutional layers to make the final classification. Okay, so this information is useful to determine the type of the disease. Okay, so at the end, this orange color layer. Okay, so this we call as a softmax layer. So what it will do? Here we will try to understand the depth of the disease, okay, by analyzing in terms of probability distribution. Okay, so here how to understand this with respect to leaf disease detection. Okay, so every output neuron corresponds to a specific disease that is healthy or unhealthy. That depends on the available input data. Okay, so here you can convert into for understanding sake this 1 by 1 by 1,000 different categories. Okay, so here you can determine. Okay, so there's many number of diseases. Okay, using this VGG16 network. Okay, similarly, we have another deep neural network method that is inception V3. Okay, so this inception V3 also helpful in detection of leaf disease. Okay, so here the inception modules, if you see here, module A, module B, module C. Okay. sorry. So these are the core building blocks of the inception with. So these are core building blocks. Each model consists of a combination of convolution layers. So here, if you see what we discussed in the previous slides, so each model consists of various convolutional layers with different filter sizes, like 1 by 1, 3 by 3, 5 by 5. Okay, and it also includes the various max pooling layers. This approach particularly helpful in extraction of the exact features and the original information that is available in the input images. Okay, and then grid size reduction. So here, if you see in between the inception module, there is a box called grid size reduction. Grid size reduction. So as the network progresses, the size of the feature maps reduced through max pooling and convolution layers with stretch. So this helpful in network focus on more important features and reduces computational costs. So these are introduced in order to reduce the computational cost. So these are playing this grid size reduction are playing in the intermediate role between the inception module between two inception modules. Then auxiliary classifier. So this auxiliary classifier is an intermediate layer in the network. So it provides some additional learning signal during training. So here, while providing the while running during training, so it helps how quickly it can collect the data, how quickly it can process the available information. Okay, so that it will do auxiliary classifier. Then finally, fully connected layers. The fully connected layers. So this um, at the end of this network, the feature maps are flattened and fed into fully connected layers. So that is this fully connected layers. So these layers perform the final classification and producing probability distribution over the different leaf diseases categories. So as we discussed in the previous, maybe blushy, okay, or healthy or unhealthy, and if it is a diseased, okay, what type of disease. So that depends on the system that you are working. Okay, so if you are having a good amount of information in diseases, okay, you can categorize the diseases. So this is another model, Inception V3. Okay, so here I try to explain the data set that we worked various leaf images. So here I am providing some of the diseased leaves. So the upper portion consists of this is a cauliflower leaf, and the intermediate one is a mango leaf, and the next one is a tomato leaf. Okay, so here with this information you cannot say. See, if you see here the edges. Okay, so this part is healthy. Half of the part is healthy, half of the part is unhealthy. So by using this, you cannot predict. Okay, if you see here, this part is unhealthy. So if you see here, the complete leaf is having some lesions, some dark spots. Okay, so if you see in this, so like this, you cannot work for each and every leaf that is there in the field. Okay, so you need some mechanism to capture this information and store this information in terms of a data set. Okay, so see here this mango leaf. So some abnormality is presented here, some abnormality is presented here. So like this. So here we need to capture this available information from the input images. In order to capture this, okay, so you can use various cameras or mobile apps. Okay, so the device that you are based on that only you may obtain some results. Okay, this is the data set we created in order to work at IIIT NR on leaf diseases. Okay. And the working mechanism. So here you can select your interested model. So that is your CNN model. You can integrate one model with another model, or you can modify, means hyperparameter tuning. So with respect to, so that is a deep neural network. So in case of CNN, in case of VGG16 or Inception V3, how many grid layers you want, how many convolution layers you want, how many hidden layers you want. Okay, that depends on your input information collected from the images. Okay, so that's up to your need. Then the choice of data set version. So you want to work with the color images, if you want to work with the grayscale images. So if you work with the color images, so you cannot directly work with the color images. Of course, today there are some models to work with directly with the color images, but there is some problem with that color images. We cannot produce the required quality output. Okay, complete quality output. Okay, so usually in color image processing also we convert these color images into grayscale. We work with the grayscale, and again we will get restore in terms of colors. Okay, and training. So as part of artificial intelligence, machine learning or deep learning, so that depends on your interest, how much percentage of data you want to use for training, how much percentage of data you want to use for testing. The more you train, the better it may work. Okay, so some cases, some sensitive applications. So here, these deep learning methods not only applicable to this agriculture. So you may work these models for various sectors like healthcare, automobile industry. So depends on the application, you can decide your uh, choice of training testing set distribution, maybe 80% for training, 20% for testing, 60% for training, 40% for testing. So like this. So here the research industry all the times revolves with a term called accuracy. So how to obtain a good accuracy. So here how to determine the accuracy. So when you train and test with the known data, you may get good accuracy. But when you train with the known data, if you test with the unknown, means unseen data, if you get a good results, then we can say we attained a good accurate system. So like this, you can understand. So this is about some of the models of deep neural networks. Okay. So these are the references papers we worked for the work. Actually, I did not present the complete work. Okay. The complete work is available in the form of a research paper. I will show you the research paper. This is a research paper we presented in a conference, a prestigious conference called Indicon conference. Okay, so three different leaves. This is a tomato leaf, cauliflower leaf, and the mango leaf. So we collected data.
Sir, it is not
Okay, these
visible
are,
here.
it's not visible. Oh, sorry.
Your PowerPoint presentation only visible, sir.
Okay, okay. I will. Now it is visible.
Not
Ravindra sir, it
visible,
is
sir.
visible.
Yes, it is
Yeah.
visible, sir, now.
Yeah. So now this is this is a tomato leaf and a cauliflower leaf. Okay, and this is a mango leaf. So we collected the data. So this is the data set we created at IIIT Raipur. So with this data we work and we collected some features. Okay, so these are the various outputs are generated. Okay, at first hidden layer of CNN. Okay, and the fourth hidden layer. Okay, so randomly we selected wherever it is giving good results. For research paper sake, we collected the interested presented in the paper. Okay, you can go through this research paper if anyone is interested. Just search in Google Scholar or IEEE Explore this multi-crop leaf disease detection system. This is the title. This is the title of the research paper. You can get good knowledge on this research, how to detect whether the leaves are diseased or healthy. Depends on this detection, you can come one understanding or conclusion that whether it may give good harvest or good crop or not. Okay. So with this, I am stopping my presentation. Thank you all. If you have any queries, you can ask.
Inquiries are there, please. Shreya?
Yes, sir.
Yeah.
Sir, thank you so much for spending your time with us. It's gotten late, but you've still given us an amazing session, and we're very grateful to you for that.
Yeah. Thank you.
So I think there is a poll posted. Everybody, please kindly answer the poll.
Thank you, Mallikarjun sir. Thank you very much. Thanks for giving
Actually,
valuable
I have to say,
inputs to us. Thank you, sir.
Actually, I have to say thank you because there is a long association between you and me. So you invited for this lecture. Thanks to you for remembering me and for providing this opportunity to deliver. So in this short time, I may not cover all the things, but I try to give. So in other platform, we can connect and we can share. If any one of your student or peers are working on this domain, so you please connect with me. We can work more. Thank you for this wonderful opportunity. Thanks to the Hitam management also for this opportunity. Thank you, sir.
Thank you, sir. Thank you very much.
Okay. Shall I leave, sir?
Yes, sir. You can leave, sir. Thank you. Good night, sir.
Okay. Good night. Thank you.
So shall I wrap this up after the poll is answered?
So, dear all who are completed the poll session, please you can leave. Thank you. Good night. Who completed the poll session, then please you can leave. So tomorrow at the same time, we'll join together.
Where we can get the polls?
So tomorrow we will give the answers, ma'am.
Sir, I'm not able to
attempted, sir. Bye, sir.
I'm not click the submit button, but it is not.
The poll icon is not displayed in the display, ma'am. Hello.
Sir, I attend the poll, but I'm not submitted the submit button, but it is automatically went out.
Once it is done,
Moreover,
then
it is
automatically
showing 2 by 10 or something like that. We didn't get the remaining questions.
Yeah.
Gupta sir.
Yeah, ma'am.
సార్ పోల్ పోయింది సార్, అందరూ సబ్మిట్ చేయలేదు.
Okay, ma'am. I'll check it out once again.
థ్యాంక్ యూ.
Yes, sir. It is a relaunched, sir. Please verify it. Ma'am, is it okay now?
Yes, sir.
Okay, ma'am. Thank you.
Yes, sir.
Okay,
Yes,
but
sir.
there
Thank
are 10 questions, so keep it for some time.
సార్ మళ్ళీ గుప్తా సార్ మళ్ళీ డిసపియర్. గుప్తా సార్.
Ma'am, it is launched only. Please verify it, ma'am.
ఓకే. Does anyone see the poll, or this is a problem with me only?
Yes, the
Yeah,
poll is
problem with
visible.
you only.
We can see.
It is visible.
The poll is visible, ma'am.
Okay, ma'am. Okay, sir. Thank you.
Who completed the poll session, then please you can leave. Thank you. Good night.